Hello greetings and welcome to yet again another video. Today I'll be looking at algebraic expressions. Right, so an expression is simply a set of terms written separated by plus or minus, and this is without an equal sign. So that's how you tell an expression apart from an equal sign. An equal sign would be one expression being equal to another expression. Right, so in any expression, in mathematics rather, you would have types of expressions. I'm just quickly going to look at those. So the types of expressions that would have are the types that would have one term. Then if your expression consists of one term, like 2, a 3x, a 4a squared, terms like xy, and a few more. These terms are referred to as monomials. Right, monomials. Right, this comes from the fact that mono means one. And similarly, we have algebraic expressions that have two terms. Examples would include, let's have 2x minus 3, your y squared plus az, your 3 minus 2y, and etc. So for the fact that you have just two terms separated either by plus or a minus, we call such terms binomials. So we have our binomials here. And then lastly, we have three terms, algebraic expressions which have three terms. Examples include your a plus b plus c, and the most common one would be ax squared plus bx plus c. These types of terms or expressions are referred to as trinomials. And then if your terms or your expression happens to have more than three, these expressions therefore would be called your polynomials. So in this video, we are just going to be looking at multiplication of these monomials with binomials and binomials with trinomials, and sometimes binomials with themselves. Without any waste of time, let's quickly look at an example, and I will explain how one can easily get to the correct answer by following this example. So as the first one, let's look at, suppose you are given 3x plus 2, which is multiplied by 2x squared minus 5x plus 3. Right, so number one needs to understand that the brackets in mathematics, these ones right here, they represent multiplication. So how I perform my multiplication, I always have what I call the order. I am always going to follow a particular order. This order tells me that before I start multiplying or before I continue with the expression, I first need to multiply the signs. I follow with the variables. In fact, let's follow with signs, numbers, yes, the constants. Sometimes we can even look at the constants being the coefficients of these variables, coefficients, and then lastly we'll look at the variables themselves. So it means I would like to multiply the variables last. And what do variables refer to? it refers to the letters that we see in our expression. Right, and in any of these or in any of the products that we'll be dealing with, we are also going to take into account the laws of exponents. If you're multiplying powers with the same base, you are simply going to keep the same base and then you add the exponents. Same applies to dividing powers of the same base. You keep the same base and you subtract your exponents. Right, so let's see if we are given 3x plus 2 multiplied by 2x squared minus 5x plus 3. Right, the first bracket is a binomial because it has got two terms. Then the second bracket is a trinomial because it has got three terms. So now from this order of mine, it says the first thing that I need to multiply is the signs, and then I will follow with the coefficients of the variables, and then the last thing that I will multiply is variables. Right, so let's see what is it that I'm talking about. I'm going to take this 3 right over here and multiply it with every number in the second bracket. This is called the distribution law of multiplication. Right, similarly the 2 in the first bracket with every single number in the second bracket. Right, so I'm actually distributing these two terms in the first bracket to every other term in the second bracket. Right, let's check. If I'm going to take the first term, I will have the signs. Looking at the coefficient of the 3, it's a positive. Looking at the coefficient of the 2, it's a positive. I know that whenever I take a positive, I multiply it with a positive, I am going to get my positive back. And then your positive multiplied by a negative, this will give you a negative, and then your negative times the positive, this will also result in a negative. However, now a negative multiplied by another negative will give us a positive. Right, we bear that in mind. So the first one, we have positive times a positive, which gives us a positive. It's fine if you don't write it down, particularly if it's the first term. Now, the next thing that we need to multiply is the coefficients or the constants, which are just the numbers in front of the variables. So we have a 3, multiply that with the 2, you get your 6. And then we go lastly to the variables, keeping in mind the laws of exponents. So we have x times this x squared. This is a power with base x, a power with base x. The base are the same, and we multiply, so we are going to keep the same base, which is our wonderful x. Then we add the exponent. The exponent of x is a 1. The exponent of 2 of x, that side, is a 2. So 1 plus a 2, it gives us a 3. We are done with the first term. We do exactly the same with the others. Positive times a negative this side, this time, will give us a negative. Then 3 times a 5, that will give us a 15. Then x times an x, resulting into an x squared. Same applies. Positive times this positive, you get your positive. And then 3x times 3, you get just 9x. Similarly, we do with the 2 now. Positive times a positive is a positive. 2 times a 2, it's a 4 with the x squared. And then positive times a negative gives us a negative. 2 times a 5, it is 10 with the x because there's no x here. And then positive times a positive, we get our positive. And then 2 times a 3, we get our 6. Right, the main goal was to remove the brackets. The brackets are gone now. Okay, so once the brackets are gone, we are just going to look at what we call the like terms. Like terms, those are terms in an expression that have the same variables. Right, so in terms of their variables, the variables must have the same exponents. If it's a square, the other one should also have a square. Looking at those, we are going to check, is there any number with the power x cubed? Looking at the expression, there's only one, so we just bring this one down as it is. We'll have 6x cubed as it is. It has no pair. Then we look at the second highest power, which is x squared. There we have x squared, we also have x squared. Then it means these two together with their signs will form like terms, a set of like terms with this one as well. And then the second ones would be this positive 9 right here with this negative 10x right here, and then the 6 will definitely go alone. Right, after collecting my like terms, I see that I have a negative 15 and a positive 4. So how one can actually easily understand this one is to say, I'm looking at the two like terms. The first one is a negative 15, the second one is a positive 4. So you can do it without the variables, and then look at these are integers with different signs, and we know that integers with different signs, we are always going to keep the sign of the bigger integer, which is a negative, and then we simply subtract these two integers. Subtracting the two will have 15 minus a 4, we get 11. And then what is the variable that is going with these two? It's actually x squared. We do the same with these two. We have a 9, which is positive, and a 10, which is negative. Again, two integers we are trying to add, or you're trying to subtract. Simplifying these two, the integers, we take the sign with the sign of the bigger integer, which is a negative, and then we subtract. 10 minus a 9, it's a 1. And then this one goes with an x, then we'll have 1x. Right, and then the last one, we see that the 6 goes alone, then we'll have it with as positive 6. We bring it down together with its sign. So in a nutshell, this simplifies to 6x cubed minus 11x squared. And then you can write this term without the 1, because the 1 is always invisible in mathematics. And then negative x plus a 6. This is how you multiply a binomial with a trinomial. Right, let's take again another example. Suppose this time around we are given the following. Two x plus 3 multiplied by 2x squared minus 1 minus 4x cubed. Right, so in this question, again, we follow exactly the same thing that I've mentioned before. We are going to look at this. This is a binomial with a binomial, and then we subtract a monomial. And then this will give us this times this. So it's a positive times a positive, a positive. No need to write it down, so I'm just going to omit it this time around. Then 2 times a 2, I get my 4. Then x times x squared, I get my x cubed. And then I go this 2 positive times a negative, I will get my negative, and then 2x times 1, I will get my 2x. And then my positive with a positive, I will get a positive. And then 3 times 2x squared, I get 3 times 2x squared, I get 6x squared. And then positive times a negative, I get my negative. 3 times 1, I get a 3. Now what follows, we still have this negative 4x cubed. And again, once you have removed the brackets, you simplify by collecting like terms. Let's quickly look at our like terms. Our like terms, we always start with the highest variable, the highest exponent. We have x cubed. Any term with an x cubed becomes a like term with this one. So we have right here 1. We also have right here another 1. And then let's look at the term with an x squared. We only have this one. And then a term with an x, we just have this one over here. Right, and then this one is our constant. Right, simplifying these two, we see that we have a 4 minus a 4. This will give us a 0, and then 0 times x cubed is actually a 0. And any 0 number in mathematics, we just don't write it down. Right, especially in expressions. So we'll have 0 of the power x cubed. And then the following thing that follows is the one with an x squared. It is positive. Remember, if it's a first term, we don't need to write it down with the positive. So you'll have a 6x squared. And then nothing goes with this negative 2x, so you just bring it down as negative 2x. And then nothing goes with this negative 3, and then it becomes negative 3. Then our second example would be done just like that. Right, let's look at another question, and this one is just interesting. We'll talk about this one in detail in another video. Number 3, suppose now I give you x plus y, which is multiplied by x squared minus xy multiplied by y squared. Right, the same procedure applies. Every term in the first bracket by every term in the second bracket. So here I'll have positive times this positive, give me a positive, x times x squared, having x cubed. Then positive times this negative, I'll have negative. Now whenever you multiply two variables which are different, you are just going to keep the order, right? And then now we have x times xy. The x and this x are like powers of the same base that are multiplied, so we keep the same base and we add the exponent, so we get x squared. But the y, there's nothing it multiplies with, so it remains as y. Then positive times positive, it gives us a positive, and then x times y squared, it is x y squared. Positive times a positive again, it's a positive, and then y times x squared. Keep the letters of the alphabetical order in the way they come. So if you have y times x squared, you start with x squared and then you follow with y. Then we'll have x squared, and then with y, and then positive times a negative, you'll have your negative. Then y times xy, you'll have x, and then the y will square. Then positive times a positive, you'll have your positive, and then lastly y times y squared simplifies to y cubed. And then now again, once one has removed the brackets, it remains to actually do what? Collect like terms. Remember, those are terms with the same variables in terms of their exponents. Right, so we have negative x y squared, x squared y, there's another x squared y. You would see that they are exactly the same but opposite signs. So mathematically this one cancels with this one because they are going to subtract from each other. One is positive, the other is negative. Similarly, we have x y squared with x y squared. Same magnitude, different signs. So these two cancel. The only two things that we are left with x cubed plus y cubed. I did mention to say we are going to speak about this one in detail in another video. Right, we call this binomial the sum because we are adding of two cubes. Right, we will discuss the sum of two cubes when we deal with factorization. Right, ladies and gentlemen, that is our third example. Let's look at one other example. I just want to do as many as possible to explore the different ways in which they can come. The next one would be a third minus x, then this is squared. So we have our binomial, and our binomial this time around is squared. One way a person can do this is 1 divided by 3 minus x. A square tells us that the bracket is repeated twice. So we have a third minus x. Same principles, they don't change. This multiplied by this multiplied by that, this by that, this by that, taking into account the laws of exponents and the signs. So plus positive times a positive is a positive, and then 1 times 1, it's a 1. So whenever you multiply fractions, you multiply the numerators together and the denominators together. And then 3 times a 3, it gives us a 9. Then we'll have positive times a negative to give us a negative. And then a third times an x, it gives us a third x. Please bear in mind that a third x is exactly the same as x divided by 3. This is exactly the same. Similarly, negative times a positive, this will give us a negative. And then we'll have a third x. Then negative times a negative, simplifying to a positive, and then x times an x, giving us x squared. Right, similarly, we are going to start with a term with a variable in its highest power. So we'll start with this x squared, and then we follow with a term with a variable in the second highest power. So it's actually this one. But now these are also like terms. We have -1/3 and another -1/3. Right, we see that this is a fraction with the same denominator. You keep the same denominator and then you add. So you'll have -1, -1, the -1 and another -1. Two integers with the same sign, you keep the same sign and then you add. So 1 + 1 is a 2. Divide by the same denominator, which is common, and then an x. And then lastly, we bring this positive 1/9. Then a third minus x all squared simplifies to x squared minus 2x. 2x divided by 3 plus 1 divided by 9. Right, let's look at two other questions that can come. Suppose now we are given the binomials 2x plus 3 multiplied by x minus 6. This will simplify to 2 times 2, positive times positive, a positive 2x. 2 times 1, which is 2, x times x, x squared. Positive, negative, negative. Then 2 times 6, that's 12x. Then positive times a positive is another positive. 3 times x is 3x. And then positive times a negative, it's a negative. 3 times 6, you're 18. Collect like terms. 2x squared, we can see it goes alone. Right, look at these two like terms. We have -12 as the first and +3. Integers with different signs. Take the sign with the big sign of the bigger integer and subtract. 12 minus 3, you get your 9, and then you bring down the -18 as it is. Right, next expression. Let's look at an expression with y because we've been dealing with x. Let's see how the mathematics applies there. Y minus 5, then we have 7y squared minus 6y, and then we have -8 or -8. Again, a binomial by a trinomial. Positive, positive, it's a positive. 1 times 7, it's a 7. Y times y squared, it's y cubed. Positive, negative, we'll have a negative. Then 1 times 6, it's a 6. Y times y is y squared. Positive, negative, we'll have a negative. And then y times 8, it's 8y. Similarly, negative times a positive is a negative. Then 5 times 7y squared, that is 35y squared. Then negative times a negative is a positive. Then 5 times 6, it's 30y. And then negative times negative, resulting in a positive. And then 5 times 8, we get our 40. Again, you would see that the aim is to remove brackets. After removing brackets, you collect like terms. Anything with a cube, it's only this one. You bring it down. 7y cubed. Anything with a square, we have -6y squared. We have -35y squared. So it means those are like terms. Similarly, -6 is the first coefficient. -35 is the second coefficient. Signs are the same. You keep the same sign and then you add these two integers. Adding the two integers, 6 plus 35, it gives us 41y squared. And then similarly, we go to these ones. And you would realize that I also consider the sign. It's very important. These are also like terms. The first coefficient being a -8, the second coefficient being a +30. Right, integers with different signs and you add. Right, all you need to do, keep the sign of the bigger. In this case, it is now positive, so we'll keep this one. And then 30 minus 8 is a 22. Right, this goes with a y. Then we bring down the 40 as it is because it does not have a like term. Right, this algebraic expression y minus 5 multiplied by 7y squared minus 6y minus 8 simplifies to 7y cubed minus 45y squared plus 22y plus 40. Right, then for the last one, if 1 happens to be given, such an expression, especially fractions, we realize that grade 10s and most other learners are afraid of using or dealing with fractions. If you have this expression, this now is to a power of 3. So telling us that these brackets are multiplied 3 times by themselves. So x minus y all over y, 1 divided by x minus 1 divided by y, 1 divided by x minus y divided by y. Right. One way that a person can do this is to actually multiply the first two together and then multiply the product of this with this one. So we are going to still keep our brackets, then multiply these two first. Right. So I'm just going to put a big bracket around these ones to show that I'm starting with these ones. So again, multiplying fractions, you multiply across numerators, across denominators. I'll have 1 times this one. I'll have a 1. Bear in mind that I'm still using the rules. And then x times this x, I get x squared. Similarly, positive, negative, I'll have a negative. And then 1 times a 1 is a 1. Divide by x times y is an xy. Right. Negative times positive is a negative. 1 times a 1, it's a 1. Y times x, remember the order, xy. Then negative times a negative is a positive, and then 1 times a 1, it's a 1, divided by y times y, y squared. Right, this whole bracket is still multiplied by 1 divided by x minus 1 divided by y. Right, let's simplify first the bigger bracket. 1 divided by x squared, there's nothing I can do with that. Then these two are like terms, the denominators are the same, so we add the numerators. Minus 2 divided by xy, then plus 1 divided by y squared. Now we are in the position to actually multiply them out. Right, doing that, we'll have the following. Again, this by that, this by that. So we'll have positive, 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 1 times 1, a 1, divided by x squared times x, giving us x cubed. Then positive times a negative, 1 times a 1, it's a 1, divided by x squared times y, we get x squared y. We do the same with the second term, with every term in the second bracket. We have a negative times this positive, giving us a negative. 2 times a 1, we get a 2 now, divided by xy times x. We'll have x squared y. Then negative times a negative, giving us a positive. Then we'll have 2 times 1, which is a 2, divided by xy times y. We get xy squared. And then lastly, we do the last term with every term in the second bracket. Positive times a positive is a positive. Then 1 times 1 is a 1, divided by y squared times x. That is going to be x squared y. Positive times a negative, that's a negative. 1 times 1, it's a 1, divided by y squared times y, which is y cubed. Now you will see that the brackets have all disappeared. Right, now if you can check, this is more like we are dealing with the denominators. You can still look at that in that way to say any expression, a term with a third, it's only this one and only this one. So you keep the first one, 1 divided by x cubed as it is. Right, x squared y, x squared y. This is a positive, a negative, this is a positive. So you can see that these two can cancel out nicely. And then you will see also that these two we have, pardon me, yes, x squared y, there. Right, and then we will check this one. We have 2 divided by x squared. Wait, I think there's a mistake right here. Right, yes, this in fact is supposed to be, let's quickly check. This came from the last 2 terms, so we have this times that, giving us that, right? And then we are supposed to be having in fact the xy squared, not x squared y, xy squared, xy squared. Yes, so it means these two, they are not cancelling as yet. Right. Okay, pardon me again. Let me just redo this whole step so that nobody is lost. I'm just going to do it in a clean piece of paper. Right, so this is where I'm starting. I'm going to restart again from this part. So it's positive times a positive, giving us a positive. 1 times this one, it's a 1, divided by x squared times x cubed. Then a positive with a negative, I get a negative. 1 times a 1 is a 1, divided by x squared times a y, it gives me x squared y. Let's go to the second term now. The sign is a negative with a positive, giving us a negative. Then a 2 times a 1 is a 2, divided by x, y times x, I get x squared y. Right. Then a negative with a negative, a positive. Then 2 times the 1 is a 2, divided by x, y times y. This is x, y squared. Right, then the last term now, plus, because positive times a positive. 1 times 1 is 1, divided by x, y squared times x. This is x, y squared, because it's y squared times y, y squared times x, so it is x, y squared. Then positive times a negative, it's a negative. 1 times a 1, a 1, divided by y squared times y. This gives us a y cubed. Right, ladies and gentlemen, let us check what information do we have right here. So continuing from this stage, this is what we'll have, right? Like I said, this goes alone, 1 divided by x cubed. Right, then let's check. We have x squared y with x squared y. Then we have xy squared with xy squared. Right, ladies and gentlemen, these two are our like terms because they have the same denominator. Right, so we are going to keep with the same sign, keep the same sign, then keep the same denominator of x squared y. Then you add the numerators. The numerators is going to 1 and 2, which is 3. Right, then we look at these two again. They have xy squared, xy squared. Again, the denominators are the same, the signs are the same, so we keep the same sign. Add the numerators, we get a 3, and then keep the same denominator of x, y squared. Then lastly, this one goes alone, negative 1 divided by y cubed. So now, ladies and gentlemen, this wraps up our calculation of the product of 1 divided by x minus 1 divided by y all cubed. So this simplifies to this expression right over here. And then one thing that I need to emphasize is that please bear in mind that x squared y is not the same as x y cubed, squared. So if you're wondering why am I not taking these two as like terms, it's because x squared y is not the same as xy squared. Hence these two are left as they are and not treated as like terms. Right, ladies and gentlemen, that is all for today. This wraps up our session on algebraic expressions, grade 10. Please stay tuned for more. they are still going to come. Again, if you have any questions, please drop them on the comments on the video. I will definitely make sure that I get back to you as soon as you have posted them. Right, that will be all for today. Please stay tuned for more. Like and subscribe. Please share. Let us show the world that math is definitely easy. Till I see you again on another video. Cheers. Goodbye.